All right, last video. So here we've got just a couple more problems using our equations. This one we're given our focal length. It's 15, and it's creating an image that's 30 centimeters away. So we want to know what the distance of the object is. And you can use this same equation to solve for any of these three items, as long as you've got the other two. So remember, it's 1 over f equals 1 over dO plus 1 over di. We know focal length is 1 over 15, 1 over 30 plus 1 over dO. We don't know dO. That's what they're asking us to find. Okay. So I'm going to again convert these. These are a little easier looking than the ones on the previous page, but still. 0.06667. 1 divided by 30 is 0.03333 plus 1 over dO. I'm going to subtract this from both sides so I can get 1 over dO by itself. So I'm going to have 0.06667 minus 0.06667, 0.03333, 0.03334 equals 1 over dO. Again, I am not done because I gotta flip this or do crisscross. dO equals 1 over 0.03334. And I'm going to go ahead and do that in my calculator. That gives me right at 30 centimeters away. So my object is a distance of 30 centimeters away from my lens. Okay. So what is my magnification? I don't have any heights here, so I'm going to use this equation. Remember, with this version of magnification, you've got a negative sign. Okay, you need to keep that. So I've got minus my image distance was 30. My object distance was 30. So my magnification is minus 1. So I'm going to have the same size. And it's inverted, and I know it's inverted because there's a minus sign there. Okay. All right. Then mirrors. Really quick on mirrors. So with mirrors, we've got reflection happening. Okay. Reflection ends up causing light rays that bounce off the mirror, but then we've also got these virtual rays that kind of go behind or through the mirror. So let's say we've got one light ray that bounces over. Okay. It's going to bounce back same direction, but then it's also going to create a virtual ray on the other side. And then let's see, we've got another one that goes from my object. It's going to hit the mirror. It's going to bounce at the same angle because of the law of reflection. Angle of incidence equals angle of reflection. This bounce back is going to create another virtual ray. And you get a lot of rays that bounce back and forth and make their real rays on this side, virtual rays on this side. This is the mirror here in the middle. But what we end up with is an image that's virtual because it's not one that we can move around or anything. It's kind of like stuck in the mirror. It's upright or normal. And then it's going to be the same size. And this is a flat mirror. Remember, this is a plane or a flat mirror. And that's how these work. So you end up with an image that's virtual, it's upright, and it's the same size. So then last question, we got an object that's 4 meters in front of the plane mirror. So my stick figure person is going to go out and they want to see how they look. So they're going to stand in front of their big flat mirror 4 meters away. How far away would the image appear to be? it's going to be this in the same place on the other side. Okay, it's this other virtual image on the other side. So it's going to look like it's 4 meters from the object to the mirror, plus another 4 meters from the mirror to the image. It's going to look 8 meters away. It's really not 8 meters away, okay, because it's a virtual image that's kind of stuck in the mirror, but it's going to look like it's that distance away because these are symmetric, basically, for a flat mirror or a plane mirror. Okay. Okay, I guess that's the whole study guide. Good luck studying